10.4 Slope. Slope refers to the incline or the steepness of a line. There are three different methods that we can use to find the slope of a line. One is by counting, one is by using the slope formula, and another one is from the equation. For slope, we use the letter M to represent the slope. The reason why we use M is because it comes from a Latin word. The definition of slope is rise over run. And then the equation that we use to find the slope of a line is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If we want to use the counting method to find the slope of a line, we look at the graph of the line and we have to find the places on the graph where the line crosses the crisscrosses or the grids on the graph. What I mean by that is here is where it's crossing, where it crisscrosses the graph. And here's another spot where it crosses. Do you see how it's crossing the point where the grids cross? Here it's not crossing a grid. So we look for those points where it crosses the crisscross. So on this graph, I see three different places where it does that. It doesn't matter which ones you choose. Just choose 2 points, and we're going to count rise over run. So if I go from that middle point to the upper point and count rise over run, we have to stay on the lines and make a right angle. So if I count rise over run from this point to this point, I'm rising 1, 2, 3, and I'm running 1, 2, 3, 4. So I made a right angle to go from this point to this point. If I went from the very bottom point to the very top point, let's see what would happen. If I went from the bottom to the top point, that would be 1, 2, 3, 4, 5, 6. So I rose 6, and I run 1, 2, 3, 4, 5, 6, 7, 8. But if I reduce that fraction, I still get 3 over 4. If I went from the bottom point to the middle point, or actually let's say the middle point to the bottom point, and say I went from here to here. My rise, I would be going down 1, 2, 3 spaces. So that would be a -3. And then I'm going to the left 4 spaces, 1, 2, 3, 4. So if I'm going to the left, that's also negative. So that would be a -3 over -4, which would become positive 3 over 4. So in all paths that I take, it reduces to 3 over 4, my rise over my run. Let's look at another one. Again, we have to find the points where it's crossing the grids. So here is a point, here is a point, and here's a point. Again, we just need to go from one point to another point. So if I went from the bottom point to the middle point, and make a right angle. It's like you're staying on a road. You can't cut across through the grass. So I rose 1. So if I'm going up or to the right, it's positive. If I go down or to the left, it's negative. So I rose 1, and then I'm going to the left 1, 2, 3, 4. So that would be a negative 4. So my slope would be a negative 1/4. All right, if we look at this graph, I see here and here are 2 points. If I do my rise over my run, I'm rising 1, 2, and I'm running a negative 1. So negative 2 would be my slope. Again, if I did it a different way, if I went from the top one to the bottom one, I'm rising a negative 2, 1, 2, because I'm going down 2. So that would be a negative 2. And then I'm running a positive 1. So that would be a negative 2 for my slope. In this example, we have a horizontal line, and the places where it's crossing the grids would be at each one of these points. So let's say I just pick these 2 endpoints. If I go from one point to the next point, my rise, I'm not rising at all, so my rise would be 0. And my run would be 1, 2, 3. So my slope is going to be 0 because the 0 is on top. But if you'll remember my trick for horizontal lines, HOI says that if it's a horizontal line, the slope is 0. So all horizontal lines are going to have a slope of 0. Here we have a vertical line. If I were to pick 2 points on my vertical line and do rise over run, to go from one point to the other point, I'm rising 1, 2, but I don't go left or right, so my run is 0. Well, since the 0 is on the bottom, that means it's undefined. But again, from my Hoy-Vux trick, Vux says that all vertical lines have a slope that's undefined. So if your line is vertical, the slope will be undefined. Now let's talk about another method for finding the slope of a line. Earlier, I told you that the formula for finding the slope of a line is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What that means is we have to have 2 points to be able to find the slope of a line. And in every point, our coordinates are x and y. So let's look at number 1. In this first coordinate, this is my x and this is my y. Well, in my second coordinate, I also have an x and a y. So we just need to name one of them our x and y sub 1's, and in the other one, those would be my x and y sub 2's. So now that we've labeled our coordinates, we're just going to plug them into the slope formula. So if my slope formula is y sub 2 minus y sub 1, my y sub 2 is negative 1 minus my y sub 1, which is 3, over x sub 2, which is 4, minus x sub 1, which is negative 2. So if I work this out, negative 1 minus 3 would be negative 4. And 4 minus a negative 2, that would be the same as 4 plus 2, so that would be 6. And then always reduce your fractions. So this would reduce to a negative 2 over 3 for my slope. Okay, let's look at number 2. Again, let's label our points. This is my x sub 1 and my y sub 1. This is my x sub 2 and my y sub 2. Okay, y2 minus y1, that would be 5 minus 1 over x sub 2 minus x sub 1, so that's 3 minus negative 2. All right, 5 minus 1 is 4. And 3 minus a negative 2, that's like 3 plus 2, so that would be 5. And 4 over 5 won't reduce, so that's my answer. Okay, we have a couple more to try. Negative 2, 3, so that would be my x sub 1 and my y sub 1. And negative 7, 3 would be my x sub 2 and my y sub 2. Okay, when I plug it into the slope formula, y sub 2 minus y sub 1, that's 3 minus 3, over x sub 2 minus x sub 1, that's negative 7 minus negative 2. Well, 3 minus 3 is 0. And 7 minus a negative 2, that's negative 7 plus 2, so that would be a negative 5. Well, if the 0 is on top, then it's 0. So my slope here is 0. In number 4, let me label my points again. X sub 1, y sub 1, x sub 2, y sub 2. Alright, y is always go on top. Y sub 2 minus y sub 1, so that's 8 minus 4 over x sub 2 minus x sub 1, that's negative 2 minus a negative 2. Okay, 8 minus 4 is 4, and negative 2 minus a negative 2, that would be like negative 2 plus 2, which would be 0. Well, remember, if 0 is in the denominator of my fraction, then that means it's undefined. So my slope here is undefined. The last method for finding the slope is if we're given the equation, and that means it has to be in slope-intercept form. Well, remember, slope-intercept form is y equals mx plus b. And if it's in this form, the m, or the coefficient of x, is going to be our slope. Also, if we just have an x, or if we just have a y, we can use Hoy-Bucks to find the slope. If it's just a y in the equation, then my slope is 0. If it's just an x in the equation, then my slope is undefined. So let's look at some equations. In number 1, there's only an x, so because of Bucks, I know that my slope is undefined. For number 2, there's just a y. So because of Hoy, I know that my slope is 0. For number 3, I have an x and a y. And my slope is already in slope-intercept. My line is already in slope-intercept form. So the coefficient of x, which in this case is negative 1, that's going to be my slope. So my slope is negative 1. For number 4, there's an x and a y, but it's not in slope-intercept form. So we have to get it in slope-intercept form first to determine what the slope is. All right, so to get it in slope-intercept form, y equals mx plus b, I need to get the y by itself. So I'm going to subtract 3x from both sides. And I have negative 4y equals negative 3x plus 12. And then I need to divide everything by negative 4. And that gives me y equals, a negative 3 over negative 4 would turn positive, minus 3. So my slope here would be 3 over 4.